Okay, we've kind of given a definition of a function and how it's an equation or a situation that's defined by an equation or a table of values that depicts when you put in one value for x. I meant to highlight that. One value for x, you get only one value out for y. So what we're going to do now is we're going to graph a function, and it's going to be a picture showing the set of all points whose coordinates x and y satisfy this relationship, y is a function of x. There is no limit to the number of points that can be chosen. Therefore, we normally select a few values of x and obtain their corresponding y value, and then graph the ordered pairs and connect the dots with a smooth curve from left to right. So we're going to focus initially in this first segment on the graphs of linear functions. And linear means straight. If you go from, here to the bathroom and you can walk in a straight line, that's a linear relationship. So this first segment's going to be relatively long, and again, it's just going to be linear equations. So a straight line is formed by 2 points. A point here and a point here, and you can form a straight line between those 2 points. So a linear function is one where y is equal to a coefficient times x, and the variable x is raised to the first power. So there is no x squared, there's no square roots, there's no fractions involved. It's just something with an x in it. It doesn't have to be in this format, but this y has got to be to the first power, x has got to be to the first power. It could have a number off here, no problem. That's still a linear equation. And because 2 points make a straight line, we're going to choose 2 points, but typically I'll choose a third as well, just to confirm my math calculations. So I'm going to put in values for x. Remember, it said a few values for x. You get to pick and put in a few values for x. And we're going to talk about the types of numbers that can go into x in a linear function as well. Well, first of all, if I want to put in 3 points, I tend to use 0, 1, and 2 when I'm graphing a linear function. I do it because if I'm going to do this in my head, I don't like to deal with negative numbers. If I'm going to use a graphing calculator and create a table for this, oh well, I can do that. But I'm likely going to do this in my head. So the equation y equals 4 times x. So the first number I want to put in is a 0. So 4 times 0 is 0, and that's my y value. The next number I want to put in for x is a 1. Here, 4 times 1. Well, 4 times 1 is 4. And then the next number in my table here is a 2, and 4 times 2 is 8. And I'm ready to graph these ordered pairs. So I'm going to come on over here and graph 0, 0. And then I'm going to go to the right one and up 4. That'll be my next ordered pair, this one. And then here I'm going to go to the right 2 and up 8. I'm going to have to kind of estimate. So go to the right 2 and up 1, 2, 3, 4, 5, 6, 7, 8, maybe about right there. Then I'm going to do the best I can to draw a straight line between these 3 ordered pairs. And finally, you need to put an arrowhead on the end of your graphs because it's not just these 3 ordered pairs that work in this equation. I could put a 5 in for x, and 4 times 5 would give me a value of 20. I could put a -3 in for x, and 4 times a -3 would give me a value of a -12. So I often say in class there's oodles of ordered pairs that will work in a linear equation, and so these arrowheads show that I understand that I could go on and on and on. Now remember that if you wanted to do this on the graphing calculator, you can go here. I'm going to stretch the calculator out a little bit. You can go here and put in y equals 4 times x, and then you can set up your window to start at 0 and go in increments of 1, and then go second graph to see the ordered pairs that I just calculated in my head. 1 and 4, 2 and 8, 0 and 0. I think I did 5 and 20. So you can see those. One thing I haven't shown you yet is that you could back up on this table to see any negative values. So if you put a -1 into this equation for x, 4 times a -1 would give you a -4. So you can arrow through this table to see more values. Next, what I'd like to just share with you is that you could also let the graphing calculator graph this for you as well. And so I'd like to introduce the idea of looking at just the window. This is the window for the rectangular coordinate system. It's saying that, see the grid right over here that we can only see part of? It's saying that it's going to draw a rectangular coordinate system that goes to the left as far as a -10 and goes to the right as far as a +10. And it's going to put tick marks, if you will, every 1 unit. And then it's going to go downward on the y-axis. So on the y-axis, it's going to go downward a -10 units and up to a +10 units. And I'm going to go ahead and hit the graph key, and you're going to see the graph of the line that we've just graphed on paper as well. So let's see if I can shrink this down a little bit. Try it with my other mouse. And maybe move this. And look at this graph that we drew and this graph on the graphing calculator. Also, look, you could hit the trace key and it would allow you to move along this linear equation. Right now I'm sitting at 0, 0, and I'm going to move a little bit. Look at the ordered pairs on the bottom of the screen I'm going to try to get to, but I won't be able to get to 1 and 4. What I could do, because I've hit the trace key just now, I could type in a 1 and hit enter, and it takes me to the ordered pair where x is 1 and y is 4. So again, that's this ordered pair right here. Look up here on the graphing calculator. It shows you the equation that you've just graphed here. So, you know, a function can be illustrated by a picture. It can be illustrated by a table of values. It can be illustrated by the name of it itself, y equals 4x. And so I'd like to graph one more before we close this segment. I'd like to try to keep these to about 10 minutes. So I'd like to graph y equals 2x minus 3. And again, I know it's a linear equation because y is to the first power and x is to the first power. There's no radicals, there's no fraction variable in the denominator, there's no powers, x squared, x cubed, y, you know, etc. So because I know it's a linear equation, I'm going to pick these easy numbers again. And I'm going to put these values in right underneath this part of the expression. This is my equation. I'm essentially asking you initially here to find f of 0 when I want you to put in 0 for x. So you'll go 2 times 0, which is nothing, and then you'll subtract 3, and you'll get a -3. Now let's put a 1 in for x. So right here, I'm going to put a 1. Order of operations says to multiply. 2 times 1 is 2. 2, take away 3 is a -1. Let's do it again. So let's put a 2 in here. 2 times 2 is 4. 4 minus 3 is 1. And let's see if my ordered pairs form a straight line. So when x is 0, I don't go anywhere in this direction, and then I go down 3. The next ordered pair, it says x is a +1 and y is down 1. The next one is x goes over 2 and y goes up 1. And sure enough, these 3 dots do form a straight line, and so I'm going to try to draw a straight line through those ordered pairs. I'm going to remember to put an arrowhead on either one. And then finally, you know, the values for x, we've been speaking about these. The values for x are the independent variables. Independent letter. It means that when it's independent, it means I get to choose, or you get to choose. We often call that the domain of a function. So in a function, I might ask you, what values am I allowed or can I put into the function and have it work and give us an output for the dependent variable. Remember, y always depends on whatever you put in for x. So dependent, I have to wait on that to determine what it is based on what I put here. We call the output for those the range of the function. And I want you to know that for any linear function, the domain is all real numbers. The domain of any linear function, all real numbers. You can put anything in for x. You could put negative numbers. You could put positive numbers. We put 0 in. You could put fractions in there. You know, you can take 2 times 1/2 minus 3, and 2 times 1/2 is 1, and 1 minus 3, and you get an answer. So all real numbers for the domain, and then the range of a linear function is all real numbers as well. There is a symbol that I suggest that you might use for that phrase, and that is a capital letter R with kind of a double stroke. In a textbook, it'll often be with this all darkened in, but I just don't want to take the time to do that. So all real numbers can be written in an abbreviated form like this. Finally, please understand that the reason for these, that they're both all real numbers, you know, I can't really do this, but this just goes on and on and on and on in both the x and the y directions because I'm going this way and this way, this way and this way. And this goes on and on and on. Remember, I've got arrowheads on here. It just keeps going down and out of the screen. So the reason these are all real numbers is because I can put anything in for x, any real number in for x, and get any real number out. And then finally, one last thing, we saw that in the table as well. We're putting in numbers and we're getting answers out. We can go backwards here and you can see that I just keep getting, you know, values out, and I could do likewise. I could do the same thing. I'm not going to bother to go down to the positives, but the table will tell you what the domain and the range are as well.